All right. So in the past, the sort of most important thing about algebra, right? One of the things we learned was about slope, right? And this is going to be an important part of pre-calc. We know about lines, and we can know about slope, right? So let's say we have 2 points. Let's say one point is here at, let's call it -4, -2. And another point is here at 3, 3. And we have our line. Oopsies. Let me try a little bit better. A line going through those 2 points. Slope we calculate with we use the letter m, right? And slope is always rise over run, right? So we can imagine, right, this is all Algebra 1 stuff. Just a little reminder, right? We have rise and we have run. Which our formula for slope, y2 minus y1 over x2 minus x1. Formula for slope, right? So here, right, we do 3 minus 2 minus -2, that would be 5. 3 minus -4 is 7. So the slope here is going to be 3 minus -2 over 3 minus -4. Negative negative becomes a plus, plus a positive. Negative negative plus a positive. So this line is going to be 5 over 7, and that's our slope. Right, stuff you've seen for 4 or 5 years now. As a reminder of different kinds of slope, right? As a reminder of different kinds of slope, there are 4 types of slope that are important. 4 kinds of slope. There is positive, and that is a slope that is going up to the left. Negative slope, and that is down to the right. There is a zero slope, right? And that is a straight, flat line, right? The equation of these is like y equals some number. So that's 3 slopes. And our last kind, so when you have y by itself, that's a slope of 0. And then our 4th slope is undefined. And this is when you have a vertical line straight up and down. And this is an x equals a number. X equals -3 or x equals 6. You have an undefined slope. Zero slope, the way you can remember, or like if you ever get confused, wait, which one was 0, which one was undefined, think about the definition of slope, right? Slope is rise over run. So if you look at this 0 slope, right, the rise of this is 0, right? The run is here. Run is some number, but the rise is always going to be 0. So this is always going to be 0 over... What happened? Stop it. This is always going to be 0 over something, right? Your rise of a 0 slope is 0. You're not going up and down at all. Rise is 0. Here, your rise is some number, but your run is 0. You don't go side to side. So this is going to be some number of run, right? Let me just do this. Let me say so number sign. Let me write the word over run. This will be rise over your 0 for your run, right? So in a 0 slope, your rise is 0, and in an undefined slope, your run is 0. That's 0 on the bottom of the fraction means this is an undefined number. Can't do that. Okay. Questions so far? So 4 types of slope that are important: positive, negative, 0, and undefined. I'm going to move stuff up. If you need me to move something back down, please yell at me. Let me know. So the way we use slope, of course, is with linear equations, with lines, right? There are 5 types of equations of a line. And each one has its own sort of use. Each one has its own strengths and weaknesses. You've seen these 5 types. I just want to quickly go through them to remind you of the different styles and give you some tips as to when certain ones would be useful. So first type we have slope-intercept. Slope-intercept. This is our y equals mx plus b. Right? M is, of course, our slope. B is, of course, the y-intercept. So I should say, do this in a color. Some fancy colors here. Type 1, slope-intercept. So how are they useful? Slope-intercept is useful for graphing. If you want to graph something. Good for graphing. Good for graphing equations. Right? You have your slope, you have your y-intercept. That's pretty useful. Good for graphing things. It's helpful because it gives you the slope and the y-intercept. So if you're given those pieces of information, you can write the equation immediately. Slope-intercept equation You're given the slope and the y-intercept. Pretty easy to write the equation, pretty easy to graph. Y equals mx plus b. Second kind, let's call it a point slope equation. So point slope. Point slope formula. And this is y minus y1 equals m x minus x1. x1. Y minus y1 equals m times x minus x1. x1, let me try to write this better. It's called point slope because you have a point. Y1 is a point. And m is your slope. x1 comma y1 is some location on the graph that the line goes through. And m is your slope, right? M is slope. x1, y minus y1 equals m x minus x1. Point slope is very useful when you want to write equations. Useful. It's good for writing equations. Good for writing equation given a point and a slope. If you're told a location of the graph and you're told the slope of the graph, you can write this equation exactly, directly, right? Good for that. Or just given, instead of a slope, just given, or given 2 points. Good when given 2 points. All of these equations are the same thing, right? They all produce the same result. They all make an equation of a line. You can translate between any of these kinds of equations, right? But some are useful in other situations. So knowing how these are useful, that'll be good. All right. Third kind, we have a horizontal line. Right? Horizontal line is an equation y equals some number. Let me make y equals some number c. And c is a constant. Sum of value. Y equals c. C is a constant. Horizontal lines, of course, useful for graphing straight lines. Horizontal line, its slope is 0. And it's parallel to the x-axis. So horizontal lines, y equals a constant value. Slope of horizontal line is 0, parallel to the x-axis, right? And just like we have horizontal, we also have vertical lines. Vertical line, vertical lines. And those are x equals some constant. here, the slope is infinity. Slope is undefined. And it's parallel to the y-axis. So those are 4 of the lines. And it's important to know all these different kinds because they are important for different reasons. Vertical lines, you might need, you need to know like the properties of it. What is it useful for? How do I make a vertical line? If I want a line that's going straight up and down, how do I create that? I create that using x equals a number. That's going to create an equation that's a vertical line. How do I create a horizontal line? These are y equals numbers. So knowing the rules, knowing these definitions, is what is key here. And our last kind, oh god, nope, I don't like that color. That's real bright. No, let's not do that. Let's just put this, I suppose. Our last kind is what was called standard form. Standard form. And it's ax plus by equals c. And a, b, and c, oh, not 3, a, b, and c are integers That means they are not fractions. So this standard form uses just straight integers, and this ax plus by equals c. This is probably the least useful form of an equation. Standard form. We don't really use this a lot. You can see some equations in this, but it's not very helpful for us, right? Like y equals mx plus b, we use that all the time. That's for graphing. You know the slope, right? A and b and c, it sort of doesn't really tell you the slope. It doesn't tell you any intercepts. Maybe you can find some intercepts. So one of the uses of this is you can find the x and y intercepts. This down here, try to write this a little bit better. These are integers, and what this says is this is not fractions. Not fractions. So one of the uses of this standard form is you can find the x and y-intercepts by plugging, x is 0, plugging y is 0. And the other big use for this is for word problems. You're trying to balance things. Problems or balance problems. If you have two things like the price of hot dogs and the price of hamburgers, and you're trying to balance them. Or you're trying to buy soccer balls and basketballs. You want to balance these things. Yes, not fractions. That's what it says at the bottom. So with these kinds of equations, we want to do some, we want to use these, right? We want to use these equations to solve problems, to answer questions. We want to use these forms of equations to work things out. So let me show you an example. Let's do an example. Find an equation of the line through the points 1, 3 and -5, 0. Find an equation of a line. Find the equation of the line that goes through those 2 points, 1, 3 and -5, 0. You could do this in a lot of ways. One way you could do this is maybe visual. If you were to graph these points and maybe like figure out and do a drawing, but you may not have graph paper, or you may not want to take the time. And is there a way we can do this? Like, what's the most efficient method we could use to solve this, right? So when we see that we want an equation of a line, right? When we see these words, right, equation of a line, you have two, you need to find, there's one really key thing you need to find. Must find your slope. When it says equation of a line, think about these 5 different types of lines and think about how you're going to find an equation of that. Well, when you write equation, when you see the word equation and line, you know you're going to need a slope. Equation of a line, you need a slope. So let's find my slope. Slope m, we have rise over run, it's y2 minus y1 over x2 minus x1. In this case, that's going to be, let's see, this is going to be x1, y1, and that's x2, y2. So let's do my subtraction, right? I always go backwards from the 0 to the 3, right? The second point minus the first point. So 0 minus 3 over second point minus the first point. It doesn't really matter which direction you go as long as you do the same way, but I'm going to do it my way. I remember how to do it backwards. -5 minus 1. So 0 minus 3 is -3. -5 minus 1. What is that? Is that -4? -6. Yeah. Careful with your positive negatives. Make sure we're doing that okay. -5 minus 1, -6. So -3 over -6, we can simplify that. We can simplify that, divide them both by 3. That's actually, negatives will cancel out. 3 is 1, 6 is 2, so this is going to be 1/2. So that's going to be my slope for this equation. So we have our slope. What else do we need? Looking at our 5 examples, which is maybe the most useful? Which of these is the most useful to use to find the equation? Standard form? No. Forget your standard form. I don't know why you're here. And that's not horizontal and vertical. We don't need those. We got slope, intercept, and point slope, probably one of these. Again, these are probably the more useful ones. These first 2 are going to be the most used. Since we don't have the y-intercept, I have to use, not have to, but I'm going to use this point slope form. Y minus y1 equals mx minus x1. I have to pick a point. I know my slope. I need to pick a point. Well, I have 2 choices. I could pick either one of these to be my point. It doesn't matter. Both will work, right? If I choose this 1 and 3, or -5 and 0, which one do I want to use? Someone give me a suggestion. Which one should I use? 1, 3, or -5, 0? 1 and 3. Someone says 1, 3. This is a good idea. These are both positive numbers. That's helpful. Anyone think I should use -5, 0? Anyone think this is more useful? Yeah? Yeah, this is pretty good too, because it's got a 0. Right? That 0 is pretty useful. It's going to maybe like make some stuff simpler, make some stuff go away. And the more stuff I can make go away, the better. I'm going to use the -5, 0. Let's do that one. So let's see, I've got my point slope form. My equation. I'm going to use y minus y1 equals mx minus x1. So I'm going to use this point here as my y1 and x1. Y minus y1, and now be careful, make sure you're using the y, right? Red. Green. Y goes with y, and I guess I'll use yellow. X goes with x. Don't get confused. Y minus 0 equals my slope, which was 1/2. X minus my x value here is -5. Plug them into the right spots. And we're done. This is an equation. This is an equation. God, I really need to practice a little bit more with this tablet, everybody. Hold on. This is an equation. We have an equation of a line. We are done. It's maybe not the prettiest equation, right? And maybe we could simplify this a little bit more, and that might be helpful. But we don't have to. If it says write an equation, you got an equation. If it says write an equation in a particular way, maybe you want to do it that particular way. But let's do a little bit of simplifying just to make this clean up a little bit. Like, for example, this -0, we can just really take that away. Right? That 0 just goes away. And this minus makes a plus. So let's just like simplify. This is going to be y equals 1/2 of x plus 5. And that's pretty good. That's pretty good. If we wanted to graph it, maybe we would also, right, like distribute this 1/2. And I have y equals 1/2 x plus 5 over 2. And this is now graphable. This is y equals mx plus b. But this is correct. Even this was correct. And this is correct. All of these are all correct. All correct. Writing equations of lines. Questions so far? Is that okay? I got 15 minutes. Let me do one more example of how we can use these. So lines, not only are lines useful for creating just random equations, right? We use math, right? The purpose of this pre-calculus class is to figure out, we've done all the tools, right? You've seen what I'm showing you right here. You've seen this lots of times. Making a line, this is nothing really new. Refresher, perhaps, but not new. The way I want you to start thinking about it is to take a step back and look at the bigger idea. A linear equation, the reason we use these equations, the reason we want to talk about math is to use it for modeling. So we're going to do something called linear modeling. The reason we want this equation is to make some like predictions about stuff, to learn about something in the world. I care about the world. I care about how math can help me understand the world. So let's say you're Nike, right? And you're looking at your sales for a couple of years. In 2004, let's say you had 12.25 billion in sales. And in 2008, 4 years later, you had 13.74 billion in sales. Let's say you were Nike and you were looking at these numbers. And you're like, okay, here's my situation. I'm selling these many shoes in these years. Let's make some predictions. How much 13, yeah, let me move this a little closer. 13.74. $1 billion in sales. Let's say you were Nike and you were like, okay, well, we got these sales. This is our sales for 1 year, our sales for the next year. We see it's going up. If I wanted to make a prediction, let's say I want to like plan out my business, can I predict how much we'll make in sales in 2011? Assuming we're growing the same, assuming everything is constant, assuming we have a linear model. How much will we make in 2011? How do we make this prediction? Well, so we have 2004 to 2008. We can see how many years we grew. Right? That's 4 years. Right? So we increased 4 years plus 4 years. And we also increased in our sales, right? Plus, what is that, 1 point something billion? Some amount you can figure out. What we really have here, these data points are not just like random numbers. These are coordinates. You can think of these as coordinate points. 2008, 13.75, and 2004, 12.25. These are points. Right? This is our X, and this is our y. Years are the x and the sales are the y. And so this is the 13.74. That's a 4. Thought I'd make it easy on you. Make it 5? No. Whoopsies. 4. 13.74. These are 2 coordinate points, and we can use those coordinate points. We can make an equation, then plug in 2011 for x. So like the reason we use this model, we're gonna create a model which is an equation. That equation is going to like do the predicting. It's the equation, it's the model that we use, and then we take that model, we say, okay, well now tell me what is the price in 2011. We can use that model to predict the future. Ooh, predicting the future. I gaze into my mathematical crystal ball. So let's make our equation. Instead of, so we have our 2 points, right? 2004, 12.25 and 2008, 13.74. Instead of these big numbers of years, though, very often you will want to recalibrate your years, right? Instead of 2004, 2008, we can start this by saying, okay, let's pretend 2004 is our starting year 0. We recalibrate. Recalibrate our years. Recalibrate. It's an A. So 2004 becomes 0. That means that 2008 becomes 4. It's 4 years later. My values I can't recalibrate, but I can find my slope. Find my slope by doing the same thing before I've done, right? y2 minus y1. That's 12.25 minus 13.74 over my x's. 4 minus, oopsies, I'm doing this wrong. Uh-oh. Uh-oh. I did the wrong order. I want to have my later one first. 13.74 minus 12.25 over 4 minus 0. So let me do a little math. 13.74, break out the calculators, 12.25. That's 1.49 over 4. And since we're doing decimals, I'm just going to make this decimal 0.3725. 0.3725, and this is my slope. A decimal is fine. I can make this a fraction. I can leave it like 1.49, but like because we're dealing with fractions here, your decimal, because we're dealing with decimals, your decimal slope is totally fine. Slopes can be all kinds of numbers. They don't have to be a fraction. They can be decimals. This is just great. So I have my slope. Just like before, we want to make a y equals, we want to make an equation, right? We want to make an equation, so we're going to use the same equation we used last time, our point-slope equation. Right? Y minus y1 equals mx minus x1. And I'm going to decide which point to use, and probably this first one is a good one to plug in because it's got a 0, right? this will be x1 and y1. So plug them in. I'm going to get y minus y1 is 12.25 equals m x minus 0. Oops, m, sorry, not m. I know what m is. My slope, 0.3725. X minus x1 is 0. $12.25. And there's my equation. Again, we can simplify this a little bit. Simplify. Y minus 12.25 equals 0.3725 times x minus 0 is just x. So I don't even need the parentheses anymore. I can just say x. And then I can add this 12.25. I can just add this to the other side, 12.25 plus 12.25. And I get y equals 0.3725x plus 12.25. Why did I cross it out here? Don't cross it out there. 12.25. And I have my equation right here, which is my model. This is going to be used to predict what I want for my sales. X is the years. This is the year. And Y are my sales. How much money I made. So we want to know what it is in 2011. So should I put 2011 into X here? Not since we recalibrated. Remember, I made 0 2004, 4 2008. So if 2004 counts as 0, 2011, 4, 5, 6, 7, 8, 9, 10, 11, that's going to be 7. So 2011 is becoming a 7. And so I plug this in. Plug in for 2011. And remember, 2011 became 7. So I've got y equals 0.3725 times 7. 7 years I grew. Plus 12.25. And again, break out the calculator. 0.3725 times 7 plus 12.25. This means my total sales 14.8575. 14.8575. And that's the sales in 2011. And you see what happens, right? We had 12, 13, so this is 14, so that's a little bit more. So we go back and check to make sure it all makes sense. And we used a linear equation as a model to make a prediction. And that's the point of this pre-calc class. How do we use these mathematical tools to be helpful? All right, like I said, I will post these to Schoology for sure. I actually also made a recording of this, me writing these. It's just recording the whiteboard screen, nothing else. You do, however, have a homework assignment. Oh boy, your first one. In the book, on page, this is chapter 1.1, page 11, I would like you to do the following. Numbers 1 through, let me see, I had it written down. 1 through 10, all. And then 25 through 40, 25 through 45 odd. Yep, that's what I want. I'll post this to Schoology as well. Page 11, on our first section. This is going to be due on the next time we meet is going to be Monday. Okay? Yeah, it's lunch right now. I know we went over a little over time. That's it, everybody. I'm going to stop sharing my screen, and I will see you next time. Yeah, say goodbye in the chat. That's fine. And once you say goodbye, you are free to go. I will see you next time. Thank you all very much.